Upbeat, intriguing music fades in and then lowers to a background hum. Have you ever looked up at the night sky and wondered what's really out there? Beyond the stars and planets we can see, lurking in the cosmic darkness, are some of the universe's most mysterious and powerful objects, black holes. For decades, they were the stuff of science fiction, theoretical monsters that would crush anything that dared to get too close. But what if I told you that visiting one might not be just a fantasy anymore? What if the technology straight out of Star Trek was closer than we think? Let's rewind to 2019. It was a landmark year for astronomy. For the first time in human history, we saw the unseeable. The Event Horizon Telescope, a global network of radio telescopes working in perfect harmony, captured the first ever direct image of a black hole. There it was, a glowing, fiery ring of superheated gas and plasma swirling around a circle of pure nothingness, 55 million light-years away in the Messier 87 galaxy. It was a jaw-dropping moment, a picture that confirmed decades of theory and changed our relationship with these cosmic giants forever. Before this, black holes were just elegant equations on a blackboard and mind-bending concepts. After this, they were real, tangible destinations in the cosmic ocean. This image wasn't just a pretty picture. It was a beacon, signaling a new era of exploration. It proved that we could peer into the very edge of space-time and see the silhouette of infinity. The scientific community was buzzing, and for good reason. It was like seeing a photograph of a dinosaur for the first time after only ever seeing its fossilized bones. Suddenly, the beast felt real, and the desire to see it up close became more intense than ever. The momentum didn't stop there. Just a few years later, in 2022, the Event Horizon Telescope team did it again, but this time, they brought the discovery much closer to home. They unveiled an image of Sagittarius A*, the supermassive black hole hiding right in the center of our very own Milky Way galaxy, our galactic heart. Seeing our own black hole, even as a fuzzy, mesmerizing donut of light, was a profoundly personal moment for humanity. It's like discovering there's a massive, mysterious engine room at the core of your own city. These two images, M87** and Sagittarius A*, were more than just scientific achievements. They were a cosmic 1-2 punch that completely reshaped our understanding. They suggested that black holes aren't just rare, exotic oddities. They are a fundamental, almost common, part of the universe's structure. Almost every large galaxy, including our own, seems to have a supermassive black hole at its core, acting as a gravitational anchor, shaping the stars and systems around it. This discovery has huge implications. If they're so common, doesn't that make you wonder, could we ever actually go and see one for ourselves? This is where science fact starts to sound a lot like science fiction. The idea of a human mission to a black hole is without a doubt one of the most ambitious concepts we could ever entertain. The challenges are, to put it mildly, astronomical. First, there's the distance. The nearest known black hole, Gaia BH1, is about 1,600 light-years away. Even with our fastest current probes, that journey would take tens of thousands of years. But the bigger problem is detection. Supermassive black holes like Sagittarius A** are relatively easy to spot because they have a massive gravitational influence on the stars around them. But what about the smaller stellar mass black holes? These are formed from the collapse of a single massive star, and they are incredibly elusive. They are the silent hunters of the cosmos. Unless they are actively feeding on a nearby star, creating a bright accretion disk, they are virtually invisible. They don't emit light, they swallow it. Finding them is like trying to spot a black cat in a coal cellar at midnight from a mile away. So, to even begin planning a mission, we first need a revolutionary way to map out these hidden hazards and potential destinations across the galaxy. We need a new kind of cosmic cartography. So, how do we bridge this immense gap between where we are and where we want to go? We need a technological leap, a quantum leap, really. Think about the starships from our favorite sci-fi shows. The USS Enterprise from Star Trek didn't just crawl through space, it bent the rules. It used a warp drive to manipulate the fabric of space-time itself, contracting space in front of it and expanding it behind. This allowed it to travel faster than the speed of light, without technically breaking the laws of physics as we know them. Is this pure fantasy? Well, maybe not entirely. Scientists, like Dr. Harold Sonny White, a former NASA warp drive specialist, have been working on theoretical models that suggest such concepts aren't impossible. just incredibly difficult. We're talking about needing to harness exotic matter and unimaginable amounts of energy. But the core idea manipulating space-time is a serious field of study. Beyond propulsion, a mission to a black hole would require a spacecraft with unprecedented durability. It would need to withstand intense radiation, navigate chaotic gravitational fields, and, most importantly, protect its human crew. We need shields that can deflect high-energy particles and an onboard AI smart enough to make life-or-death calculations in milliseconds. The technology required is truly mind-boggling, a fusion of advanced propulsion, materials, science, and artificial intelligence that we are only just beginning to imagine. It's a shopping list for the future of engineering. But here's the most exciting part. Every single one of these impossible technologies is being worked on, in some form, right now. Physicists are probing the nature of space-time in particle accelerators. Engineers are developing new, ultra-resilient materials. AI is advancing at an exponential rate. Each discovery, each breakthrough, is another small step on this incredible journey. The first image of a black hole was a dream just a generation ago. Now it's a poster on a bedroom wall. What seems like science fiction today has a funny way of becoming the science fact of tomorrow. Think about it. Jules Verne wrote about a trip to the moon in 1865. A little over 100 years later, Neil Armstrong took that one small step. The journey to a black hole is our generation's moonshot, but on a galactic scale. It will require global collaboration, relentless innovation, and a belief in the power of human curiosity. We are standing at a thrilling crossroads in history. We've seen the shadow of these cosmic titans. The next logical step, however distant, is to go and stand in that shadow ourselves. The future of space exploration is not just about visiting other planets. It's about reaching for the very limits of our understanding. And a black hole is the ultimate destination. What was once impossible is now merely improbable. And the improbable is what we humans do best. The cosmos is calling, and sooner or later, we're going to answer. Thank you so much for joining me on this cosmic adventure today. If you're as excited about the future of space exploration as I am, make sure to hit that like button and subscribe to the channel so you don't miss our next journey into the unknown. See you in the next one.